Welcome to Lecture 9 of an Introduction to Computer Science with Python. And today we will be covering else and implicit type conversion, which you'll see in a second. And actually we will not be covering math. A quick note, coding is case sensitive. What that means is that a lowercase is different from uppercase, and coding can sense that. And that means that F lowercase and F uppercase are different. Just as F lowercase and B lowercase are different. So you have to, all the words in Python, you have to make sure that you're capitalizing them correctly. And you're probably not going to capitalize most of them at all. So for example, print is all lowercase. If you have a capital P, then it's going to not recognize what you want it to do. And so this will probably have an error, meaning that it will probably stop your program and stuff. Errors are bad. A recap of last week. So when I was introducing if statements, I was talking about passport. And if the user entered N for no, I don't have a passport, we wanted to say that they couldn't travel. And this is how we accomplish that. So we take the input. It's either going to be a Y or an N, hopefully. And then we start out, and then we make a variable called have passport, and that value is going to be false. Remember, F is capitalized for false. And this is why capitalization is important. Capital F, capital T for false and true. If passport equals Y, meaning if passport has a value that's Y, then we want the have passport variable to be true because they have a passport. So then if you have a passport, you can travel, and we wanted to print that. And if you not have a passport, meaning if you don't have a passport, you can't travel. And this program is pretty simple, but yeah. And we're going to improve last time's code. First of all, this is not great. Firstly, if have passport was true before the two if statements, that is, if it's true here, then the first statement would always run and the second would not. And this is actually, this is true here, but it's not always going to be true everywhere. Most ways of using if statements rely on two if statements, where if the first one is true, then you skip the second one. And if the first one is false, then you skip the first one and only do the second one. I kind of worded that badly here, but I think I just explained it pretty well. And there actually is not a guarantee that that happens unless if you do some very special things, or you can also guarantee this with else, which means otherwise. And else is the easiest way to guarantee that one of them always runs and the other one always does not run. And, well, actually it means that exactly one runs and exactly one does not run. So, let's say that we are the security thing at an amusement park, this thing, where you can scan a ticket and you can spin the bar thing and then walk through. Once you scan a ticket, once you use the ticket, you can't use it again. And that's the whole point of getting tickets. And the program that we are making will take in a number. And that number is going to be how many tickets someone has. And if that number is greater than 0, we let them in. And we remove 1 from that number. Otherwise, we cannot let them in because they have not purchased a ticket. And at the end, print the number of tickets that they have left. So, some examples. If they input -5 as how many tickets they have, which isn't realistic, but, for the sake of argument, -5, then you cannot enter, and now you have -5 tickets. Because you can't take from them a ticket if they don't have a ticket, or if they have negative tickets. Again, negative tickets don't really make sense, but let's just roll with it. You can also have 0 tickets, and if you have 0 tickets, you can't enter, so you still have 0 tickets. But if you have 1 ticket, then you can enter, but you have to take away 1. So now you have 0 tickets. So there are a couple of ways to solve this. And one of them is separate if statements. So first, we take the number of tickets as an input. And remember that input is a string. So if we want to compare it to other numbers, we need to make it an int. Ints are whole numbers. So num tickets equals int num tickets will transform the input from a string to an int. If this number is greater than 0, you can print, you can enter. but you also want to make num tickets smaller by 1, because that means that you took a ticket away from that person. The way we accomplish this is num tickets equals num tickets minus 1, and the way this works is that num tickets minus 1 is first determined or calculated or whatever, and then num tickets becomes this value. So if num tickets is originally 5, 5 minus 1 is 4, so now this number is now 4. Alternatively, you can say num tickets minus equals 1, but that's a sort of convenience thing that I don't feel comfortable sharing it yet. But if num tickets is less than or equal to 0, then you want to print that you cannot enter. And now you can print you have num tickets left. Notice that I'm using the commas, and I will cover this a bit more later. But what this does is that it prints you have space after a comma. It just prints a space. Then it prints num tickets, then another space, and then it prints tickets left. And you don't. And this is a very easy way to accomplish that, and I will show this more later. Let's also cover if else. So num tickets equals input, enter the number of tickets. This is all the same. This is also all the same, but this bolded one is a bit different. Else, colon, print you cannot enter. And this means if num tickets is greater than 0, then you do this, and you skip this, and you just go here. But if this is false, then you jump to here and do whatever this is, and then you just move on. And this is else really just means otherwise again. So true, do this. Otherwise, do this. You never do both, you only do one. And there is a problem with the first one, and that is that you need to write a bit more. So if the number of tickets is 1, then, actually no, this is not related. You just need to write a bit more. So if you look at this, this is a lot more stuff to write than this. Another problem is that if the number of tickets is 1, then the code incorrectly prints both. That is, the code incorrectly goes through both this first one and this second one, which is not what we want. So you can see that if it's 1, 1 is greater than 0, so you print you can enter, and that number becomes that number minus 1. So now num tickets is 0. Then when you hit the second one, num tickets is now less than 0. So this is true, and this is also true. So it actually says you can enter, and then you cannot enter, and then you have 0 tickets left. And this is not what we want. Again, if it's 1, you just want to say that you can enter, and now you have 0 tickets. To solve this issue, you can store the initial bool, again, boolean, true or false, as a variable. And then you can say if whatever variable the first time, and if not that variable the second time. And this avoids having the condition change in the middle, meaning this will always be true and this will always be false, or this will always be false and this will always be true. And this avoids having this thing change in the middle, and guarantees that only one of them runs. But it also means that you have to write even more code. Else is clearly the better option, because else also guarantees this, but you don't have to write as much. But if you're interested, this is how you would write it. You would make a new variable enough tickets, and this is a bool. If enough tickets, you can enter, and if not enough tickets, you cannot enter. But this is kind of really hard to do a bunch, especially since if else is such a common thing to see in code. And if you're doing this a bunch, you'll actually end up slowing down your program by a little bit. So it's just better to use else. And I believe this will be the last thing. Implicit type conversion is fancy vocab to say that if you leave a non-bool for an if to see if it's true or false, it will automatically convert that expression to a bool. So this green box and this blue box are the same thing. So foo equals 0 if foo, print foo was 0. Else, meaning otherwise, print foo was not 0. Foo equals 0 if bool foo, these are the only two lines that are different, print foo is 0, else blah blah blah. And these do the same thing. So if it's not a bool, then Python will automatically make it a bool. Yeah, so that's it. This is a rather advanced topic, and is also something that's kind of limited to Python, meaning that usually only Python can do this kind of thing. Other languages like, C++, you might be able to get away with it, but particularly in Python, it's very easy to do this. However, if you are not confident about this, then I don't recommend that you do this, because this is just a more specific or precise way of saying this. It's a more verbose way, if you know what that means. And I also would not recommend this if you don't know that the 0 means that the int, if you say bool of 0, that's false, and bool of any other number, it's true. If you don't know these kind of things, then I do not recommend you to do this. But if you do, then please feel free to use it. Alright, I do believe that is the end of the lecture. Thanks for your attention, and I may see you in the next one.